Welcome to today's lesson. I'm Siamasaka Kirian Dens. And so we are going to go straight away, solve a question in chemistry, and that is organic chemistry. So I urge you to listen attentively. The first part of the question goes as follows. 4.2 grams of gaseous hydrocarbon Z was analyzed and was found to contain 3.6 grams carbon and 0.6 grams hydrogen. The relative formula mass of the hydrocarbon Z is 28. Calculate the empirical formula of Z. So for us to calculate the empirical formula, we are going to look at carbon and hydrogen. We are told that the mass for carbon is 3.6, while that of oxygen is 0.6. The second step is that we are supposed to divide by the relative atomic mass. So the relative atomic mass of carbon is actually 12. And the relative atomic mass of hydrogen is 1. So we are going to say 3.6 divided by the relative atomic mass, that is for carbon, 0.6 over 1, which is the relative atomic mass of hydrogen. And what we get here, we get actually, when we divide 3.6 divided by 12, gets 0.3. And then here we get actually the same, 0.6. So this is the ratio which we are trying to get here of atoms. And so the step which follows is that we are supposed now to divide by the smallest. So 0.3 is the smallest here over 0.3. Everywhere we are going to divide 0.6 divided by 0.3. And 0.3 divided by 0.3 is 1. 0.6 divided by 0.3 is 2. And so our empirical formula, we are going to have carbon 1 atom, while hydrogen 2. And normally we don't write actually the 1, so we are going to have actually the simplest formula or the empirical formula as like that. And so this is the empirical formula. And now we have to calculate the molecular formula. Using the information provided above, deduce the molecular formula of Z. And so we are supposed now to calculate the molecular formula of Z. And for us to calculate the molecular formula, since we've been given the relative formula mass, so which is 28. So we are going to say the empirical formula multiplied by a factor which we don't know, which is x, should give us actually 28. And therefore, when you are getting the relative molecular mass, you have to multiply the subscript multiplied by the relative atomic mass of that element. So the subscript for carbon here is 1 multiplied by the relative atomic mass for carbon, plus the subscript for hydrogen here is 2 multiplied by the relative atomic mass for hydrogen, which is 1, or multiplied by a factor x, which gives us actually 8. And so we have 12 plus 2 multiplied by x, which gives us actually 28. And so here we have 14 x. When you add 12 plus 2 is 14 multiplied by x, which is equal to 28. And therefore now we can multiply and divide by actually this factor, which is actually 14 here and 14 there. Therefore, our x will be equal to 2. Therefore, our molecular formula now would be actually this multiplied by our factor, which is x. And remember, x we have found to be 2. And therefore, we're going to have 2 atoms of carbon. And when you multiply 2 times 2, it would give actually 4. So we have identified we have calculated the molecular formula. So this is the molecular formula. Part B, write the structural formula of hydrocarbons Z. So we found it to be actually, this is actually ethene. So we need to write the structural formula. Since alkenes have a double bond, therefore we're going to, between carbon and carbon, so we're going to have double bond between the 2 carbon atoms, and then put the hydrogen, the 4 atoms of hydrogen. And remember that around each carbon atom there should be 4 bonds, 1, 2, 3, 4, signifying that there are 8 electrons, because 1 bond represents actually 2 electrons. So this is the number B. And C, to which homologous series does hydrocarbon Z belong? We have already stated actually. It belongs to alkenes. Homologous series. Okay, it belongs to the alkenes homologous series. Number D, write the general formula to which homologous series Z belong. So number D, the general formula is actually, you have to have carbon, and the N there is the number of atoms, and hydrogen multiplied by, which is the hydrogen 2 times N. So this is the general formula. And number E, Hydrocarbon Z was bent in limited supply and adequate supply of oxygen. Right balance chemical reactions for Z and oxygen in the two cases. So we'll start with the limited supply of oxygen. So we're going to have ethene, which is a gas, reacting with the oxygen, which is a gas. And what you'll produce here is carbon monoxide, which is a gas, plus water vapor, which is also a gas. And so now we need to balance this equation as we have been asked to do so. So carbon atoms here, there are two. So we have to put two carbon atoms there so that it balances. Hydrogen atoms, this side there are 4, this side there are 2. So we need to put a 2 there to make them 4. Oxygen, this side now we have 2 plus 2, which is 4. So it means that we need to put a 2 here. And this is an incomplete combustion reaction. Because what is produced because of incomplete burning of the ethene in oxygen, so you produce a poisonous gas, which is actually carbon monoxide. So you have ethene here, you have oxygen, and you have carbon monoxide. And you have water actually produced. This is the reaction for incomplete combustion, meaning that the supply of oxygen was not adequate in this burning process. When there is actually adequate supply of oxygen, in the instance where there is adequate supply of oxygen, the combustion process or burning process would be actually be as follows. That is ethene, which is a gas, would react with oxygen, which is a gas, to produce carbon dioxide plus water, which is a gas. Carbon dioxide is a gas. So we have to balance this equation. 2 carbon atoms this side, so we need to put 2 there. Hydrogen 4 here, so we need to put a 2 there to make them 4. Oxygen, so this side you have 2 times 2, which is 6, plus 2. 2 times 2, which is 4, plus 2, which is 6. And therefore, we need to have 3 atoms as a subscript here, 3 times 2, which is 6. So this is a balanced equation. So what you produce is actually carbon dioxide and water vapor. So you have ethene reacting with the oxygen, And here what you produce now is carbon dioxide. And water. So this is actually a reaction for complete combustion. What it means is that actually the burning process was actually complete. So number F, right? The reaction of hydrocarbon Z with chlorine in the presence of sunlight, use structural formulas for the reaction. So they are saying we have to use structural formula. So we have our ethene. This is a structure formula for ethene as we stated it earlier, plus chlorine, and they are saying this process actually is taking place in sunlight. So what you produce now, these bonds are going to break. You are going to produce their hydrogen, their hydrogen, their hydrogen, and here chlorine, and here chlorine, and their hydrogen, because there are 4 atoms of hydrogen. And so you have ethene reacting with the chlorine. Chlorine actually is yellow. So what you produce here is dichloroethane. Dichloroethane. Which is actually colorless. It's a colorless liquid. So this is the reaction which actually takes place, where ethene reacts with a halogen in the presence of sunlight, and you produce actually this substance which was produced. In this case, since it was reacting with chlorine, and we have 2 atoms of chlorine, we will form dichloroethane. Be careful, it's no longer now ethene, but it's dichloroethane, because this is actually an alkene. So, number G, hydrocarbon Z was bubbled in aqueous bromide. Write the chemical reaction using structural formulas for the reaction and state what you observe in this reaction. So similarly, the ethene, we are taught to use the structural formulas. The ethene actually was bubbled in bromine. Bromine is actually brown. So what you produce, the bond will break. So what you're going to have is the 4 carbon atoms. And then bromine. So what you produce is dibromoethane. Ethane, which is actually colorless. It's a colorless liquid. So you have your ethene, and here you have your bromine, bromine reacting with ethene, and you produce actually dichloroethane, which is a colorless liquid. So what do you observe? Actually, what you observe? Observation is that the mixture changes from brown to actually colorless. Actually, this is the test for the presence of an alkene. So if you want to know the presence of an alkene, you just actually react it with the bromine liquid, and what you're going to produce is actually this is bromine liquid. This is the liquid. So what you are going to produce is a colorless, colorless substance. And so there is now an exercise which has been given, which you are supposed to attempt to answer. Write a chemical reaction equation for ethene and hydrogen using specified catalyst. What type of addition reaction is this? Number B, explain 2 methods you can use to test the presence of an alkene. Number C, hydration reaction of alkene is an important reaction. Write the chemical reaction of ethene with water. State the required temperature, pressure, and catalyst for this reaction. Use the structural formulas for the chemical equation you are going to write. This is exercise number 1. Exercise number 2, the hydrocarbon T contains 85.7% of carbon and 14.3% of hydrogen by mass. Calculate the empirical formula of hydrocarbon T. Hydrocarbon T has a relative molecular mass of 84. Find the molecular formula of T. So you have to attempt these 2 exercises. And then for the feedback for your answers, actually you can contact me using this email address, ksyamasaka@gmail.com, or WhatsApp number +260 977 419949. And then we can arrange on how actually you can give a small token for the labor that I'm going to do. Thank you.